Okay, in this video, I'm going to go over the lesson that we did in class on determining the shortest distance from the point to the line. So um, the first thing you should ever do when you see a problem like this is I like to think of a quick sketch. So I call that kind of step 0. So before we start any kind of analytic geometry problem, it's nice to sketch. It allows us to assess whether our answers are going to be reasonable. So there's my point A at 1, 0, and there's my line. I've sketched it by finding the y-intercept, which is -2, and then the slope is -2, so I'm going down 2 over 1. So our goal is to find the shortest distance between point A and the line. And we talked about in class how that shortest distance is always going to be along that perpendicular or right-angled line. So any other line that you can imagine from A to y equals -2x minus 2 is going to be slightly longer or much longer than that right-angled purple line. So we want to figure out, our goal here is to figure out that the lengths of that purple line. So our first step is to find the equation of both lines. I already know the equation for the black line. And because the purple line is perpendicular, I know its slope is going to be the negative reciprocal. It's going to have the opposite slope. So if I flip -2, I get positive 1 over 2. So I know the slope of that line. And I also know that I want to find the equation in the form y equals mx plus b. So I already know m, 1/2. And I also know a point on that line. I know that a is 1, 0. So I can plug in those coordinates, 1 for x and 0 for y, and then I can solve for b. And I'm going through the algebra quickly on this video. You're welcome to pause and work through it on your own. But the idea is to find an equation of the line. I need to find the slope and the y-intercept. So there I have the equation of the purple line, y equals 1/2 x minus 1/2. And you can look on the screen and say, yeah, that looks reasonable. It's got a slight positive slope, and it looks like it does have a y-intercept at around -1/2. So it's always good to stop and say, hey, is that reasonable? Our next step is to figure out where the purple and the black lines intersect. And so we can do that by finding the POI using the method of substitution. So what I'm going to do is, because y is already isolated in both equations, I can just sub 1 into 2. Another way of thinking about this is I'm setting the right sides of the equations equal to each other. Now I've got one equation with one variable x, and I can look to solve that. I don't like fractions, so what I do first is to get rid of the fractions. I'm going to multiply by the denominator of 2. So I'm multiplying every single term on the left and right side by 2. And then I'm going to move all my x's to the left side, move all my constants to the right, and then divide both sides by -5. So the x-coordinate of that intersection point would be -0.6. I can plug that back into either equation to find the y-coordinate. I'd rather sub into y because there are no fractions. So when I follow BEDMAS, y is -0.8. So I've now found that point of intersection, and I can add that to my graph. So now I have both points on that purple line segment that represents the shortest distance between A and the black line. So there are quite a lot of steps to this problem. My first step was finding out both equations. I need that to find the POI. I need the POI because that gives me now both the starting point A and the ending point P of that shortest connector. My last step is going to be to find the actual distance. The distance between 2 points is the same as the length of the line segment, so I can use my length formula, which we talked about earlier in the unit. And all I'm doing is now plugging in coordinates of point A and point P. Go slowly as you plug in coordinates. What I'm really doing is I'm finding the difference between the x's, that's my horizontal distance, and the distance between the y's, that's my vertical distance. I'm going to square both of them. Whenever I square any number, negative or positive, it becomes positive. I'm going to add them together and then take the square root. So my shortest distance between point A and the black line occurs when I go to point P, and that distance is 1.79 units. And again, does that look reasonable? Sure. The purple line looks like it's, maybe a little bit less than 2 units on the grid. So I always recommend, as you go through each step of these problems, is to assess whether the answer is reasonable. Then I can add kind of a concluding statement. Okay, we're going to do one more example together. Again, we went through this in class. This is just meant to be as a refresher or for students who were absent. My recommendation, again, is to do what you can on your own by pausing the video. And then if you get stuck or need some extra help, you could play the video, and I'll go fairly quickly through the steps. Again, Any analytic geometry question, I think it's easier if we can visualize a sketch. I've got two campgrounds, point A and B, which are connected with a road. A is at 0, 4, B is at 12, 10. I'm only including positive numbers on this grid, so the far left we could consider the y-axis, and the bottom we could consider our x-axis. And then I have a ranger cabin at point R, 8, 15. And again, I want to figure out what's the shortest distance for me to connect a side road from that ranger cabin R to the main road in the campground. Again, the shortest distance is going to be that perpendicular line, that right-angled connector, which I've roughly sketched. Maybe it's not exactly there, but at least gives us a rough idea. That looks like it's around a right angle meeting point. And so it looks like that point of intersection is going to be maybe 10 and a bit as my x-coordinate, and then maybe 9 and a bit as my y-coordinate. So it's nice to kind of think of an estimate before I start the problem. It's going to allow me to check my algebra as we go. I need equations now of two lines, the black line and the purple line. Let's do the black line first. To find the equation of the line, I need the slope and the y-intercept. I could count out the slope. It looks like I'm going up 2 over 4. So I think my slope is going to be 1/2. I could also use the slope formula. I reduce the fraction. Again, that kind of makes sense. I'm going up 1 over 2. My equation of the line, my target form is y equals mx plus b. I could plug in either point. Here I've plugged in 0, 4 for x and y. So b is 4. And maybe you saw that b was 4 right away because point A is actually the y-intercept. So my equation for the black line is y equals half x plus 4. It starts at 4. It's going up 1 over 2. Let's do the purple line. Again, we know it has to be perpendicular. So the slope has to be the negative reciprocal or the opposite. The opposite of 1/2, I flip the fraction and I change the sign. It becomes -2. Again, my target, y equals mx plus b. I know m. And I can also plug in the coordinates of any point on the line. The only point I know on the purple line is 8, 15. So I plug in 8 for x and 15 for y. And then just in a couple steps, I'm going to solve for b. So I'm going quickly through the algebra. You're welcome to pause it and work through it on your own. But the idea is to find the distance of this purple line, I need to figure out the ending point where purple hits black. But to find any point of intersection where two lines meet, I need both equations so I can solve a linear system. So now I've got two equations. Is the purple one reasonable? I think so. Negative slope makes sense. And if I followed this purple line all the way up to the y-axis, it would connect, way off the screen. So maybe plus 31 makes sense as a y-intercept. So now I want to find that POI. I have two equations, two unknowns. So that's a unit 1 system of equations problem. And I can again just sub 1 into 2. I don't like fractions. Multiply everything by 2. That's going to get rid of my fractions. And now I can rearrange. The negative 4x becomes a plus 4x. So I get 5x on the left. And I take away 8 from 62. I get 54. And so to solve for x, I just divide by 5. Decimals are okay, especially when you're working on these sort of real-life problems. I have an x-coordinate of my POI. I think at the start we said, yeah, it should be around 10 and a bit. Again, my sketch is not an exact graph of the situation. And plug x in to either equation. I picked equation 2 for the lack of fractions. So y is 9.4. So I've got that POI of 10.8, 9.4, which looks where it should be on the graph. So each time you do a step, I would stop. The key question in this unit, maybe the key question anytime you do any sort of math problem, is, is that reasonable? Does that make sense? And I think, sure, it does. My final step is to figure out the length of this purple side road. So between R and P, there's my length formula. It doesn't matter what order you do P or R in. When I square it, it's going to be the same positive number. All 4 coordinates are positive this time. That makes it a little bit more straightforward. If I square a positive or a negative, it's still going to be a positive because negative times negative is positive. And I take the root. Yeah, that kind of makes sense. That purple line looks like it's, somewhere, you could say between 5 and 10 units. 6.26 looks reasonable. To start of the questions, I know I went through this quickly. We said that each square on this grid or this map was 500 meters. So I would just multiply by 500 meters to find my final answer of 3,130 meters. So these are probably the longest math questions that we've done in this course. So I would work through it in chunks. I would stop often to say, is that reasonable? Does that make sense? Because what we don't want to happen is you to finish the whole problem and you made a mistake back to the very beginning, and then you've got to restart the whole thing. So a good way to avoid that is to have your sketch, your graph, and keep asking yourself, hey, is that reasonable? Am I on the right track? So that's our shortest distance lesson. We spent, maybe half an hour, 40 minutes working through this together in class, and this video is, only 5 or 6 minutes. So if you have any questions, please shoot me an email. But there's our lesson on the shortest distance between a point and a line. Okay, thanks for watching.